Hello and welcome to today's webinar, Data Wrangling for Agile Analytics with Tony Baer and Sean Kandel from Trifacta. Thanks for joining us. It looks like most of the folks are on the line that are available to attend, so we'll go ahead and kick off. Just a few housekeeping items today. We will be taking questions throughout the webinar in the chat window. So if you would like to find the chat window and enter a question at any point during the webinar, if there's an appropriate moment to jump in, we'll ask the questions during the session, and we'll also be leaving time at the end to answer any questions that have come in. So we'd love this to be an interactive session with everyone. My name is Stephanie McReynolds, and I'm the Vice President of Marketing here at Trifacta, and I'll be moderating today's webinar. I'm very pleased to have two data experts on the line today. We have Tony Baer, who is an analyst at Ovum, and he has been involved in the data space for many years. He was here at the emergence of the BI and data warehousing space in the 90s and has seen a lot of evolution of data management tools and technologies, as well as analytic insights. And so we're very pleased to have him on the line. He'll be opening today's session with a little bit of background on Agile Analytics and how it's changing in the new world of Hadoop and late binding infrastructures and what that means for data wrangling in today's environment. And then we also have today Sean Kandel, who is CTO of Trifacta and co-founder. Sean was working with Joe Hellerstein and Jeffrey here as part of the data wrangling project, which was a research collaboration between Stanford and Berkeley before Trifacta was founded and was the original inspiration for the Trifacta product. So we're very pleased to have him on the line as well to give a little bit of an introduction to Trifacta's version 2 product and walk you through a use case. So without further ado, I'd love to kick off and hand the mic over to Tony Baer to give us a little bit of background of what's changing in the data space around data wrangling and Agile Analytics.
Okay, thank you, Stephanie. And thank you. Good morning, good afternoon, good day to everybody. I'd like to thank you for taking time out of your day to join us in our discussion on exploratory analytics and data wrangling for Agile exploratory analytics. The fact is that when we look at, when we look at all, let's say the hype, and I would also, say mythology of big data. Keep hearing about all these pieces of like Harvard Business Review has said that the data scientist is the sexiest job of the 21st century. Well, that's great if we could all put that title on our business cards, and I suppose we could go to to Vistaprint and do that. But the fact is that just going to Vistaprint is not going to solve our problems in terms of getting insight from big data. And the other, the other reality is that there will always be a demand for data scientists, and the supply will never be adequate to meet the demand because basically the nature of the demand is going to it's going to be a moving target. And so what do we do to make big data analytics and insights available, and useful for the rest of us? And that's really what this is all about, and that's why basically that the need for agility, the need to basically get a handle on data wrangling becomes just ever so important. So anyway, over the next, over the next half hour or so, just some of the themes that we'll be covering here. We're going to first look at the big synergy, what we call the big synergies, the synergy between exploratory analytics and big data and where it fits into what we consider to be the analytics life cycle. And then why agility is just so important for this, why if you're going to conduct exploratory analytics, that you will need to be able to be agile. And then we'll take a look at, what's the role of data wrangling? Where does data wrangling fit in all this? How does this enable, agility so that you can conduct exploratory analytics? It all fits into place at the end of the day. Can we go to the next slide? Anyway, this slide is probably review for most of you, which is that big data really has broadened the target. It's a lot more, not just a lot more data in terms of volume, but a lot of different types of data. And the significance here is it's data that which we traditionally did not capture with analytics. It was, I mean, it didn't easily fit into either it didn't fit into a SQL database because, the data was just, the structure was just too variable, or the volumes were just, enormous. And so, yes, we've structured data has been a mainstay for analytics, but now, with big data, we start to open up the tent. We start to look at, text, or basically look at, discussions and dialogues on social networks. We're tapping mobile data and machine data from the Internet of Things, and we're also able to look and introspect rich media. So it's not just a blob of rich data, but we can actually go in there and derive, basically metadata from a lot of these, rich, let's say video or audio video, artifacts. So it's very exciting, and that's the whole possibility of big data. But what it does, is it really forces us, it allows a lot of different types of analytics. Can we go to the next slide? It really allows us to ask different types of questions. And we're going to be using this, and we're not going to go through a whole rundown of use cases here, but for the purpose of our discussion today, we're going to look at one example, which is the whole area of customer engagement. And traditionally, with customer engagement, with traditional analytics, we looked at customer interaction, how they interacted with your organization. With big data, as we start to widen out, the spotlight, we can now take a look at customer behavior, understand it, work with it, hopefully in an honorable way, influence it. The idea here, ideally, and this is especially true if you basically do any type of mass consumer marketing. The idea here is that customer engagement has evolved from managing the touch points to hopefully becoming immersed with the customer's life and their lifestyle. Can we go to the next slide? So we're going to now drill down a little bit on what we were just describing. So traditionally, when we did the customer 360 view, it was a very interaction-driven type of view, and that was driven by basically a customer comes into your, if you're a retailer, comes into the store, whether it be a brick-and-mortar store, whether it be an online store, or has a contact to a call center or emails, and that was traditionally the way that organizations got a handle on their dealings with their customers. So admittedly, they supplemented this with research on things like on mechanisms like focus groups. But the fact is that if we were trying to optimize our dealing with the customer, we were dealing with how the customer was coming to us. This was really a very reactive approach. We typically use a data warehouse or a data mart for this. Can we go to the next slide? So with big data, what this does is it really adds another step to the process. It doesn't replace anything, but it adds exploratory analytics. So we can start to look around and see just what are the right questions we should be asking. Where should we be looking? What data should we be looking at? And so so it does not replace, it doesn't replace, having to understand customer interaction, but it supplements it. So for instance, we're trying to find out what are customers, saying about us on social networks, or who is really influencing what our customers are saying. Now, that in itself is not a new question. But traditionally, we've had to answer this question through very indirect methods. And now with big data, instead of doing sampling to focus groups, we can actually look at the social group in, the social tribes in which the customer is in. We can take a look at all of the data. And we can then look at, and we can get a more direct view, for instance, our external factors impacting what customers are saying and doing, such as, let's say it's wintertime and you're selling very, let's say stylish overcoats, stylish down, ski jackets or something like that, and all of a sudden the temperature has dropped by 20 degrees and now we see a rush to the stores. Well, that's an external factor. Can we predict this? Or if, let's say, if you live out in California and you're starting to see the Pineapple Express start to approach you, and hopefully that may make a contribution towards solving your drought. How is that going to impact, let's say, sales, of outerwear? Again, this is a type of data that we can now ingest in real time and look at what are people saying about this. Can we go, and by the way, I should say that with this, we're using a lot of different data sources, Hadoop, and a lot of NoSQL databases. But anyway, so what exploratory analytics is doing is we're looking for the right questions, but we're also looking for the right data sets. The idea here is that we're no longer limited, no longer restricted to the enterprise walled garden of data, which comes from your transaction systems mostly. And so we start looking at, sources, such as social networks, Facebook, Twitter, Instagram, and so on. We're starting to, we're starting to look at, external data feeds, which we can now ingest in real time. And we can take a look at, let's say, data from the Internet of Things, which can help us, get some insight on supply chain, status. For instance, GPS devices in delivery trucks going from, to the distribution center, from distribution center to the loading dock. Are they going to get there on time so we can get, so for instance, if you're in California, we can get that rain gear into the stores today in time for the deluge tomorrow. Can we go to the next slide? So this kind of, reinforces what we were saying before, which is that exploratory analytics does not replace what you're already doing. It supplements it. And this is kind of a way that we've tried to visualize this, which is that you're taking data from varied sources. You may have varied knowledge regarding its lineage, regarding basically, how valid the data is, how relevant the data is. But it's basically widening out the target. And in turn, this becomes really an iterative process. This, with regard to your traditional analytics. Your traditional analytics were performed on data, from inside your enterprise walled garden. And so this process can kick off in many ways. It can kick off with, maybe I'm starting with a question in my data warehouse. In other words, do I need to stock more raincoats? And I take a look in my existing inventory data. But I've identified some gaps here in terms of our customers. Do customers need raincoats? Are they talking about this right now? And so that's where this could trigger some exploratory analytics where we start to look at what are people saying out there. Do we expect there's going to be a rush in the stores? And in turn, we start to identify some factors, and from that we may identify some data sources that may be useful for adding and augmenting our traditional data warehouse. So this is really a very iterative process. It's very bidirectional. So this really is meant to show that it really adds to, it doesn't replace the need for the precise picture, and it can enrich it. And also, it also basically changes basically the idea. One thing we didn't really focus on is that with big data, you're doing schema on read as opposed to schema on design, and that does change, for instance, the nature of the types of queries that you can do. We'll talk about that in a moment. Let's go to the next slide here, which is we're going to talk about why agility is essential. Can we go to the next slide? Okay, so what we're doing here with exploratory analytics is that we're constantly testing hypotheses. So, for instance, we want to take a look at the stock of raincoats. And so, for instance, our purchases and call center dialogues and chats, is that adequate to gauge what customer demand is? Or should we start to compare customer and product lists with maybe what we're getting from some of our business partners? Maybe it might be, let's say, other merchants that are, that we have relationships with that maybe sell, supporting gear. For instance, could be, let's say, like wearable smart devices. For instance, is there some sort of synergy there, or basically with other types of fashion accessories, where we might, consult, let's say, with other stores. In turn, we look at basically, should we start to look at social networks, and for instance, what are the relevant hashtags or tags on photos that we should be looking at that would provide us some insight that can understand, can help us understand what customers are thinking right now and feeling. And the question is, what about social tribes and dynamic? Basically, is buying a raincoat something that's going to be, is that going to be influenced by what social group, what social tribe the customer's in, or is it going to be influenced more by weather? The answers could be surprising, but that's again what testing these hypotheses are all about. So therefore, are these social tribe and group dynamics driving customer actions, or has basically external factors such as we've just seen the weather report, is that going to basically drive it? These are hypotheses that we're constantly trying to test. Can we go to the next slide? So therefore, to start answering these questions, we need to take a look at what are the right data sources. And part of this, for instance, in looking at purchases, well, should we start to conduct market basket analysis? And the fact is, this is not a new concept, but big data actually has really, by allowing us to really widen, the spotlight out into much bigger and broader and deeper data sets, we can now start to widen out our views. So where, for instance, it used to be beer and diapers, it can get to more personal things, such as, for instance, when that department store started looking at doing a market basket analysis and correctly identified which teenage girls were about to get pregnant, and which, it was socially an awkward moment for that retailer, but it proved the validity, it proved basically the effectiveness of conducting market basket analytics and starting to do this with and conducting this, linking factors that otherwise seem to be unrelated or intangible. Now, another part of this is, as I said, should we start to look at data from partners? Well, what partner list should we analyze? Who are the relevant partners? And, from partners, what data sets that they offer that they will provide access to will be relevant to answering this question. The other question is also, are we looking at the right social networks? And of course, basically, networks, you might compare, let's say, something, say, like Pinterest versus Twitter, for instance. Is one going to provide a greater, indicator regarding, regarding basically the need for necessities versus the desire for style? And the question is buying a raincoat a matter of style or a matter of necessity? And then, of course, if we are looking at some of these social networks, which are the right hashtags or tags that are going to provide, shed some light on this? Or looking at social tribes, what criteria can we use to best identify which are the right groups that we should be looking at? And in terms of looking at social groups, are we looking at the right connections? Because when you do many-to-many analysis, that means it increases the number of potential permutations when you're looking at all these connections. And again, which tribes or groups are going to be relevant for evaluating, the effectiveness of your target marketing? Can we go to the next slide? So the key factor in being able to do this is that you need to be able to fail fast. I'm not the only person saying this. There are a lot of folks out there. I was at a presentation yesterday, a discussion on Agile analytics. Fail fast is a very it's something which is being very widely talked about at this point, and for a very good reason, because if you are trying to test hypotheses, you need to be what's implicit in all this is that your first hypothesis is probably not going to be the correct one, or even if it is, the only way you're going to find out is if you get the chance to test some incorrect hypotheses. And so in order to do this, you need to be able to, as soon as you find that something is leading to a dead end, you need to be able to back away fast. You need to be able to fail fast. Failure is going to be part of this process. And so, for instance, when we're looking at those partner lists, we have to, at some point, we might pick the right ones, but we might pick some ones that are not relevant. We need to back out of that. Same thing with dealing with the social network mix, or basically realizing, oops, we made a wrong guess on those hashtags. Let's look at some new tags. Same thing with the idea of what criteria we use for identifying which are the right social tribes to be looking at and which are the right criteria in terms of, let's say, the statements and actions that members of those tribes are taking, and also, of course, the mix of groups that we're looking at in terms of evaluating the messages that are going between them. This is very much of an iterative process, and there's going to be it's going to involve a lot of, conclusions that are just going to be plain flat out wrong, and if that's the case, you're on the right track. Can we go to the next slide? deal with all this is that when you compare this to the process of setting up a data mart or an enterprise data warehouse, traditionally, and I kind of gave this short shrift before, but we'll go into this a little more in detail, which is that when you do traditional analytics, you are selecting the data, you're putting it into a schema, and it's based on the types of queries that you expect to ask. So you're kind of setting your whole sort of, the whole query, process kind of in stone ahead of time when you put out a data warehouse. And that's diametrically opposed to what we're trying to do with exploratory analytics, where we're testing hypotheses. And the fact is that the old processes were basically you go to IT, you identify a data set, and then they do an elaborate ETL process to basically get this data to populate your data warehouse or data mart. Is just not going to work when you're conducting exploratory analytics, because you're going to be constantly shifting these data sets. You're going to be constantly shifting the questions that you ask. So you're not going to be able to wait for IT to basically get through its backlog so you can test that next hypothesis. IT cannot stage a new data mart each time the data sets or the queries change. Can we go to the next slide? And so that's really where self-service comes in. And this is kind of interesting here because basically, recall, it was right after the Romans got chased out of Rome. No, but basically when BI and data warehousing emerged, the whole, there was a moment of euphoria at that point, because now we could start to ask not just what is happening, but why is it happening. And the whole vision at that time was that there were going to be like visual dashboards on everybody's desktop. Well, things did not quite work out that way. These dashboards were proved to be a little too complicated. But what's kind of neat was that in recent years, folks like Tableau and Click basically proved that it is possible now to allow users to really get control of their own destinies here and populate their own visualizations and build these things very quickly. Yes, it did need IT help, but the fact is it allowed users to basically set up their own charts and visualizations very easily, and it was just incredibly cool. And so that has sparked a whole renewal of interest in BI and data warehousing, conventional analytics. But the thing is that what it's also done is it's proven that it's feasible to allow users to get control. The fact is that for exploratory analytics, we're going to need to embrace this whole self-service concept, but we're going to need to extend this. This has to go further from just consuming data in a visualization, building that visualization, to actually preparing it. So demand for self-service is going to extend upstream to preparing this data so that end users can really take control of this sort of agile, exploratory analytics process and basically keep mounting new data sets and new visualizations and so on. Can we go to the next slide? So basically, we've been asked this question many times, which is basically, who does it take to really put up a big data project? And we actually did a whole body of research on this roughly about a year ago after we did a tour of our clients over in Asia Pacific, and they were basically kept asking us, how do we get started in doing all this? Who are and part of that question is, who are the people or who are the players that need to get into place? And so we actually came up with sort of a list of roles, not necessarily individual titles per se, because in some cases, there's some of these roles, for instance, like data architect and DBA may be the same person, or basically your evangelist and your business owner and sponsor of the project may be the same person. But anyway, so these are basically some cross section of the roles that you need for this. When you talk about agile analytics, it means empowering basically people on the analytics and business side. And these are all the folks that we have basically highlighted in yellow here. So basically, you are empowering the domain and subject matter expert. You're empowering the business owner and sponsor. Doesn't mean that you still don't need those Java and Python developers or those data architects. But the fact is that you need to lessen their reliance on them, because every time you change that data set or ask a new question and try to map out that data, you can't afford to keep going back to that developer and say, okay, can you populate for me a new data set and perform some new ETL? So agile analytics really means empowering these folks to take charge of basically of more and more of these tasks, so they become more and more self-reliant in building their analytics so they can keep testing out their hypotheses. Can we go to the next slide? So where does data wrangling fit in all this? Let's go to the next slide here. And this part we're going to go through pretty quickly because Trifacta folks will give you a lot more detail on what this really involves. But basically, data wrangling kind of picks up, from where traditional ETL leaves off. Traditional ETL is really a matter of basically doing this very exacting type of process to populate a data warehouse. Data wrangling kind of refers to a process where we're really in exploratory mode. We're really trying to get a sense of what sets fit with each other. We may not get to fully dedupe everything, but we want to basically get, let's say, it's kind of like a good 80-20 type of process, which is we're really trying to get a sense of what data sets fit together, what variables may be relevant. As we said before, business analysts cannot rely on IT to constantly do all these transformations. And so basically, one of the things that we found is that, for instance, as I mentioned before, schema on design was how you built traditional data warehouses. With exploratory analytics, you're doing schema on read, but doing that does not ensure agility unless you're able to do what we're highlighted down below, to quickly be able to make that data consumable without the need to memorize database schema, because that was a key part of ETL. Whereas if you're data wrangling, hopefully you're not thinking about what is the final structure of this. You're trying to just figure out how the data fits together. And this is a case where essentially you're starting to widen out the spotlight so wide that you're starting to deal with multiple data sets. And the fact is that you're going to need the system to kind of help you along here. And this is where advances in machine learning really come in handy, because the system can now help you figure out, it's kind of like a Google type of thing of like autocomplete here. We can kind of figure out that this looks to be a name, this looks to be an address, and this looks to be some data that, maybe some privacy data like an account number that, well, maybe we need to obscure. We need to leverage machine learning to help basically help users make sense of these unfamiliar data sets. Can we go to the next slide? And so we're just going to run through this very quickly. The folks at Trifacta will go through this in their part of the presentation in more detail. But basically, it starts with letting the system profile your data. And this is to some extent a capability that we've had with traditional data quality, but we're really widening this out so that the system is conducting, is basically doing a lot of learning. And the idea here is that it will make an hypothesis. You will then it will then present to you, let's say, an interface where you can basically say this looks right, this doesn't look right, and the system learns from the conclusions it's drawing from the hints that you are giving. And so this is a case of where you can let the system sort of start to figure out, where this data falls into place, and essentially give you an idea of, the layout of your data set and things like factors like sparsity and so on. Can we go to the next slide? Anyway, so this is just a very, a rough view, which is that, this is just a visualization. This is what these data sets are probably going to look like, and this is what you want to end, have it end up as becoming. The fact is that you're going to be working with a lot of data sets, which are going to be highly variably structured, or the structure is not going to be quite as apparent. And again, this is where the system is going to help you figure out, for instance, that in this log file that, for instance, that second column from the left is a date field, and there's a time there, so that you do not have to go there and have to basically put up that header yourself if that header happens to be missing, or that header happens to be maybe misplaced by a column or something like that. The system will help you there, and the idea here is it's going to help you kind of organize this so that it gets into shape where you can start to now conduct some exploratory questions. Can we go to the next slide? So, in summary, big data analytics really does change the questions that we ask. And what it does, especially if we're trying to make big data analytics consumable, is it's going to add this stage of exploratory analytics to the analytic life cycle. It's not going to replace your conventional data warehousing analytics. But the thing is, to make exploratory analytics work, it's going to require an agile approach So you can constantly test new hypotheses, and you must have that ability to fail fast, to back out as quickly as possible. And the fact is, as we said before, exploratory analytics means when you test out hypotheses, many of them, if not most of them, are going to be wrong. You want to test out as many wrong hypotheses as possible, as time will allow, time and resource will allow, so you are sure that you have hit the right one or the best one. Self-service is going to be essential to making exploratory analytics happen because you can't afford to wait for IT to get through its backlogs. And again, self-service, which was proven in the BI world, with visualization, is going to need to extend back from visualization and consumption back upstream to data preparation and data wrangling to really make this happen. So that pretty much concludes my remarks. Can we go to the next slide here? I'd like to, at this point, turn it over to Sean.
Thanks, Tony, for the great introduction. I think we've been talking a lot about self-service exploratory analytics, and your example of customer insight analysis was very relevant for a lot of participants joining us today. I think one of the things that is interesting about all the data sources you mentioned in that example is that they do come in all shapes and sizes in a variety of formats, whether it be log files or sensor files or social media. So Sean would love to spend the next 10 to 15 minutes showing the audience the Trifacta product and how we deal with some of those more semi-structured data sources for self-service data wrangling.
Great. Thank you, Stephanie, and thanks, Tony. So now what I'd really like to dive into is how we at Trifacta are really leveraging machine learning and data visualization to really make this process of data wrangling much more agile and more efficient. And as Stephanie said, I'm really going to focus most of the time on a demo of our product, but just to set a little context, I'll do a few slides. So really what we've noticed is that over time, as both Stephanie and Tony mentioned, the sources of data that people are working with are really much more diverse. And at the same time, the formats that those data is coming in, whether it's Avro or C, JSON, XML, or Parquet, have really become much more complex. And the data storage platforms like Hadoop have evolved really to accommodate storing these new sources in their raw formats. But as these data sources have become more complex, the data products that organizations are creating, whether it's a new recommendation of a product or a visualization dashboard, have really become much more elegant and more simple. And what we've seen in working with these organizations is that the burden, and it's really quite a large burden, of taking these really complex data sources and manipulating them into these usable data products, that burden has really fallen largely on data scientists and data analysts in the organization. So when we kind of look at the stages of this process, there's a few different stages that analysts go through, and Tony described this really well, actually, that it's actually a really iterative process where you're exploring, and as you get to different stages, it might cause you to, find something out new or find that something wasn't working the way you thought, and you kind of iterate back through this process. And the issue is that in each of these stages, it's actually a lot of manual work, either writing scripts or transformations by hand, or a lot of manual manipulation of data. So when you kind of look at the paradigm, and this will kind of lead into what we're doing at Trifacta, traditionally the way a lot of this data wrangling work is done is by starting with writing code or data transformation scripts in languages like Python, Pig, or Hive, and so on. And as you're writing this code, it's often fairly common to then test out this code on a small subset of data or a sample of data. And as you're doing this, you might at some point kind of inspect the data, look at it either in a visualization or other format, and decide, this looks great or something went wrong, and you kind of iterate that way. But the burden of really writing the script kind of falls solely on the data analyst or the end user. So at Trifacta, our approach is really to kind of flip this paradigm on its head. And again, by using visualization, we can allow users to interact directly with the data itself, either raw values or summary visualizations. And as they interact with that data, it really triggers the system, and we'll use machine learning algorithms to take in those interactions and use those to predict the most likely data transformations that a user might want to apply to their data. As we give you suggestions, an analyst can just look at visual previews of those transformations and quickly kind of assess, am I on the right path or do I need to tweak something? And in doing so, build up this transformation script without having to write code, but instead by starting with the visualizations and the data itself. So with that, a little quick background. I want to jump into actually 2 demos if there's time. In the first demo, I want to showcase some of the predictive interaction that I was just talking about, and then if there's time, I'd love to give a kind of a preview of some new functionality we call visual data profiling that'll be out at the end of this year. All right, so I'm going to get started here. And for this demo, I'm going to be looking, for the first demo at predictive interaction, I'm going to be looking at Yelp data. And in particular, this is Yelp data that came from Yelp research. It's some highly nested JSON data on individual reviews for businesses in Arizona. In addition, we're going to mash up this data after structuring it. We're going to mash it up with data about the businesses themselves. So this is what the data I'm showing here in a text file looks like if you just pull it in kind of its raw form, so you can see some of the nested structures here. So let me show you what this looks like if we pull it up in Trifacta. So to get started very quickly, I'm just going to define a new project, which I'll call reviews, and load in the Yelp data set, which is already loaded into the system. So I'll create a project, and I'll hit transform to get started. So what you're seeing here in the interface is as soon as we load in the data, we scan through the data and we try to profile it. And as we're profiling it, we're doing a couple things. One is trying to automate this process of structuring, or at least help automate the process of structuring. So you'll see already in the top right where we have a history of the transformations that you apply to your data. There's already 2 steps that are automatically done based on what the product has inferred is the structure in your data. So what you can see here is that we first kind of split the data up, and then we unnested some of the nested structure. Of course, if the system ever gets anything wrong, it's important to support kind of quickly iterating back and forth between the transformation script, so we can always undo a step and go back to the data in its more raw format. But the data looks pretty good here, so we can continue. In addition to trying to automate some of the structuring, also as we scan through the data, we try to look at and automate some of the discovery of the data. So understanding what types of data are available and understanding the properties and distributions of the individual attributes. So for instance, in the far left here, we see we have another nested field or a nested map that's still contained in the data. As we scan across, we see a numeric column and a date column. And we infer not only the data types themselves, but also based on distributions in the data and other properties, we'll try to show you an appropriate visual summary so you can get a sense of what's really inside that data. So for instance, in this date column, based on the range here, we've bended up by year, so you can see kind of year over year the distribution of Yelp reviews. Now, looking at this data, again, as I mentioned earlier, it's still actually not completely structured. In the far left here, it does look like there's some more nested structuring that we'll want to pull out. Now, if you think about how you would normally do this, writing transformation code, you'd have to write some complex logic to kind of pull out the individual attributes into their own columns. Here, instead, what we can do is just simply select the attributes we care about. And as we select the attributes in the histogram up here, the system is recommending potential transformations that you'd like to apply to this data. In this case, recommending that we unnest these individual attributes into their own columns, and really kind of deriving these new features that could be used downstream in your analysis. I can hit the plus button here to add that step to our script, and everything we do to the data, every transformation, ends up in this reusable script, reusable logic that you can then either use for documentation or run in a production cycle as you may get new data that comes in on a daily basis or a weekly basis. Now, scanning across, we see that we have actually a lot of the attributes we need in this data. We have, for instance, the individual stars that each of the users have given the businesses. What we might want to do now is actually pull in data from the businesses themselves so we can do kind of a mashup of what do the individual reviews look like against the context of the businesses. So for that, I'm going to quickly join up the reviews data set with the business data set. So I'll go into the join tool here. I can pull in data about the Yelp businesses, get a quick sense of what that project actually looks like. We can see here there's a number of attributes, including a business ID that will probably be important for the join. And when we hit begin join, again, what the system tries to do is look at properties of both data sets, profile both of them, and understand where are the potential relationships between these data sets. In particular, what's the best way to join these data sets? So here it's suggesting that we join the business ID from the reviews with the business ID from the businesses, which actually looks good in this particular case. Of course, you can always go in and edit the keys if necessary or add additional join conditions. In this case, we have it looks good, the join condition, and we can start pulling in other data that might be pertinent to our analysis. So maybe I'll pull in the number of votes, the individuals' ratings for the stars, and then maybe zip code, so we can get a sense of kind of the location of these businesses, and finally, maybe the overall star rating for businesses, which might be useful if we want to do some analysis of are there particular individuals that kind of differ widely from the overall business rating. Once I'm done, I can add this to the script, and again, just like any other transformation, it gets added to this reusable list of transformations. At this stage, if I like, I can run this job at scale, either in kind of a MapReduce setting or Spark across a cluster, or if the data is small enough, you can also run it on a single machine. So just to give you a sense of what these jobs look like once they're complete, some of the job results, let me just jump into a job I ran earlier. And what we're seeing here is that as we run the job, similar to what we did earlier, is as we run any of the jobs that you schedule or run through the tool, we're also not just producing the raw output, but we also profile that output. So we can show you, again, interesting distributions or potentially any errors or missing values or other anomalies that we find in the data. So for instance, here we've noticed that 2 of the zip codes are missing from businesses, and that's highlighted here in the output. Additionally, give you some controls for what you might want to do with these results downstream. So when we go to export results, you can see that you can load the data in a number of different formats into different output systems, and this is highly configurable. Some of the metadata you can, of course, publish out to systems like hCatalog, where then analytic tools and visualization tools like Tableau can directly sit on top of this and read in these results into those tools. So with that was kind of a quick preview of predictive interaction. And now I want to jump in again to another feature set that we're calling visual profiling. So for this demo, a different data set, we're actually going to be looking at FEC data here. This is actually individual contributions to political campaigns. And really the goal with visual profiling is what happens when you first get a new data set? How do you understand what's in it? What fields are inside of it? Are there data quality issues that might impact your analysis? Are there other relationships between fields that are really interesting that you'd like to know about? But it's really this process of kind of uncovering or unboxing your data and understanding it kind of on that first touch. Kind of similarly, as you're transforming data and manipulating it and wrangling it, oftentimes it's really important to understand, are those transformations having the desired effect? Are you maybe introducing some type of bias into the data or doing something unexpected? So it's always important to kind of keep your eyes on the important properties of data that might impact your analysis, or at least how you interpret your analysis. So to get started, again, we see the data here. We've got some of the same profiling that you saw in the last demo at the top of each column. But what we're trying to do with visual profiling is make this experience much more robust. So by providing a much richer set of visualizations, as well as a number of other techniques for running statistics in the background so that we can point out and automate some of the process of finding interesting patterns or relationships in your data. So to get started, let me jump into a one-dimensional profile here and open up the column browser. So what we see here in the far left, again, is kind of a breakdown or a quick tour of our data. So on the far left, we see all the individual attributes, and as we scan through, we can see the distributions and data types, as well as a sense of data quality for each of these. Now, to kind of aid exploration of the data, we can organize these columns in a number of different ways. So to get started, I'll just organize by column type so you can get a quick sense of the types of data that are available. So the first one here we see is a date time column. Similarly, we have some numeric fields. We have some geography, which might be interesting, and then a bunch of kind of textual or description columns. So let's kind of dive into a specific column. Let's start off with the date that people are actually donating money to campaigns. Once we do this, we see that we get kind of a much fuller summary of the column. So in addition to looking at kind of metrics of data quality, here it actually looks fairly clean. Most of the values are valid, or actually all of the values are valid. We get a sense of some of the frequent values. What we also do is as we scan through the data, we'll try to find the most interesting charts or visualizations to show you so you get a sense of the variation or kind of uniqueness in that attribute. So for instance here, with the date time, there's a number of different ways to break it down. The system is automating this choice and deciding to bin this attribute month over month. And the reason it's doing this is because it's discovering interesting variations in the data. So for instance here we see that when you look month over month, there's actually this interesting relationship where at the end of each quarter, it looks like people are more likely to donate money. Similarly, people are more likely to donate money during the week instead of on the weekend and at the end of each month. Now, it's good to kind of look at one attribute at a time, but oftentimes it's really interesting to kind of understand how is this attribute correlated with other attributes. So as you kind of select data in this chart, you can see how the subset of data you're selecting corresponds to other interesting attributes. And to make this process even easier to kind of discover these relationships, you can actually sort your attributes by relatedness. And once you sort by relatedness, you get a sense of how is the data I'm looking at currently related to other attributes in my data set. And interestingly, what we see here actually is that report type seems to be most related to transaction date. And that might be surprising if you don't really know the data that well. But as you kind of zoom in to report type, you start seeing things like Q1. And if we select Q1, it's fairly obvious when you look back at transaction date that actually, this corresponds to the first quarter of the year. Similarly for Q2 and year end. Now, if you're most interested in, say, data quality, you can look at, say, missing values, or in this case, let's dive into some erroneous values in the data set. So when we pull up and sort by mismatch values, we see that transaction type has a fair amount of mismatch values, and then also interestingly, state has some mismatch values. So we might be curious about what's going on in there. So again, we can select that attribute and come into here. Again, you get kind of a breakdown. Not surprisingly, if we look at kind of the frequent states, the ones with the most donations, it's the larger states, so California, Texas, New York, and so on. So nothing too surprising there. We see here actually that there's an invalid value, so for some reason there seems to be ZZ, either because maybe there was a missing value and someone put that in there or so on. And when we select this value, we'll get suggestions for dealing with this invalid value. Do we want to delete all of those values, maybe set them to some other value or so on. And also because this is geographic data, of course we can plot this on a map and you can start looking at relationships on a kind of a state-by-state basis and exploring, for instance, is there some relationship between the amount people donate and the states that they're donating from? And finally, just one more feature I'll showcase here is looking at, say, extreme values in distributions. So here I sort by columns that have extreme values. We see here kind of subcommittee ID has some clusters, perhaps not too interesting. More interesting maybe is the transaction amount, which looks like it has some extreme values. So again, if we dive into here, we see most people donate, around a few $100s, maybe up to $1,000. If we expand down into kind of a richer summary, we can see a number of statistics. And to the far right, we see extreme values. So it looks like some individuals are actually donating a lot of money, but perhaps even more surprising, it looks like there's some negative values in the distribution. A lot of this information is actually down here in the histogram. Again, we see most of the values are stored around 0 or close to 0, kind of a few $100s. We can always zoom in to get a sense of what those values look like. for more detail, or if we're interested, we can select the negative values and again see how those correspond to other attributes. So with that, I'd like to end the demo and I guess open up the floor to any questions.
Thanks, Sean. We have a few minutes for questions for both Sean and Tony, so if you do have a question, please enter it in the chat window and we'll get through as many questions as we can in the next 5 to 10 minutes. We did have a question come in a little earlier. Tony talked quite a bit about schema on read versus schema on design. And Tony, the audience was wondering, how does schema on read make exploratory analytics different than traditional data warehousing analytics?
Yeah, interesting question, and the thing is that, when you think of if you don't think about it, you say, well, what's the difference? I'm doing schema, doing early binding versus late binding. But what it really does is your schema basically, drives the types of queries you can ask. So if you include certain columns of data, fine, you can query those. If you don't, you can't. And so schema on design means that you are choosing those columns, in advance, and you're kind of limiting yourself, which in a data warehouse you pretty much had to do. And it's the nature of the beast. Data warehouses are for repeatable analytics. If you're doing exploratory, where your analytics are, you're going to be constantly looking for these new relationships between different, types of data. For instance, like the example that Sean just showed, well, we found basically a relationship between a couple different columns. Well, if you added another data set, that relationship may have changed. Well, if you're doing schema on design, you will have made a decision based on that first analysis that, well, that's the only column you can look at. If you basically do schema on read, it means that, well, as we find out that this other column is relevant, we can use that. So, basically, in summary, basically, it allows you to basically kind of wander about and test different hypotheses, ask different questions. You don't have to preset them in advance.
Great, thanks, Tony. And we have received a number of questions that are probably triggered by the demo, a little more detailed on the Trifacta product for Sean. So Sean, Mike asks, is there a command line UI for Trifacta? How would the more expert user interact with the Trifacta interface?
Great. So yeah, I didn't show this during the demo, but actually the script that was getting built up while you're interacting with the data, that set of transformations, you can actually download that in a command line interface that we offer and parameterize that to run against new data sets as it comes in, or schedule that script to run on a kind of repeated basis. So you get that the way to plug it into a kind of a larger workflow or operationalize that set of transformations.
And another quick question for you, Sean. Nate had a question of can you append data easily?
Sure. So yeah, there's a number of different ways of kind of actually appending data. I showed when working with multiple data sets in the demo, being able to join data sets, but there's other operations such as being able to union data sets or concatenate them. Additionally, through the command line interface, as new data kind of comes in, you can run that transformation logic and kind of automate part of that process so that you can, as new data comes in, transform it and append it to your result set.
So one more that I have, and then if there's additional questions, we do have a few more minutes, so please enter them in the chat window. Jean asks, can you wrangle data and charts from PDF? How would someone work with that?
So we do support a variety of different formats, but unfortunately we do not support pulling data out of PDF.
Another question, can you please talk a bit about scalability, especially across data in disparate data sources? And it sounds like they have kind of a particular use case here, but I think we can address the question a little bit more generally for the rest of the audience. So, what do we do with scalability, and how has the Trifacta system be architected to support Hadoop-sized data sets?
Sure. So again, going back to kind of that script or high-level representation of the transformations I showed during the demo, one of the core pieces of our technology is actually a compiler architecture or framework for taking that kind of high-level description and targeting it at various runtimes. So for instance, I showed kind of interactive wrangling in the browser, so you get that immediate kind of experience working with data. But we can also take that logic and compile it to code that will run directly on your cluster against your data. So we can compile it down to MapReduce code, and with version 2, we can now also support Spark. So that gives you kind of the scalability of scaling with whatever your cluster can support.
So we have a pretty active audience today. There's some questions coming in, so we'll take a couple more. We'll go a little bit past the hour to accommodate the questions coming in. So a question from Drew: are there any deduplication features in Trifacta?
Sure. So there's a couple of different features actually that we support for kind of identifying potential duplicates and helping to kind of resolve and standardize them. For instance, again, I didn't get a chance to show this during the demo, but it's fairly frequent for organizations to have data such as maybe business names or other attributes where there's slight misspellings or other kind of deviations from a standard format. And we actually have technology in here or features that will kind of scan through that data, look for potential duplicates in the system, present those to a user, and the user can resolve those and map them all to a standard format.
And I think one of the things I've heard from customers that they particularly appreciate about the Trifacta technology on that front is that we do some fuzzy matching of that information, so it doesn't have to be an exact match or a rule set that's required to identify those discrepancies. So one wrap-up question, again, Sean, coming your way, and that is, how would an organization get started with Trifacta?
Yeah, so we make it fairly easy to get started. Usually, you can just contact us, and what we usually like to do is talk with, typically with folks in kind of the business to understand the analysis use case, as well as people on the more technical side, so we can make sure our software runs on your infrastructure and supports all of the scalability demands that you might have.
So with that, Sean, thank you very much for that detailed answer. Tony, thanks so much for participating in the webinar today. It was great to have your experience on the line with an introduction to data wrangling and how folks can get started with more agile analytics. And we'll wrap up for today. If you'd like to learn more or have additional questions, feel free to reach out to us through our website, trifacta.com. On the resources page, you'll find a lot of detailed information about the product, as well as the space and some good videos that you can share with your colleagues as well. So thanks, everyone, for joining today, and we look forward to continuing the conversation with you in the coming weeks.